Okay, folks, I want to do a couple homework problems with you. I need you to set up your graph paper just like I've got mine set up here. I'm going 1, 2, 3, then over here 4, 5, 6, and then on the back side, I did, the same thing. We're working up to number 12, okay? And let me just give you a quick recommendation. What I did on the backside is I took my ruler, I laid it down like this on the paper, and then I just went through and made my three y axes. Let me see if I can zoom out a little bit more so you can see the whole paper here. I made my three y axes real quick, and then I did the same over here. I made three y axes over here for my three problems. Just went like that, and then I turned the paper this way and I went over here and I made two x-axes and then two x-axes and two and so on. You get the idea. It won't take you that long. Please put down these 12 graphs. Now, guys, look, this right here, let me zoom in again on problem number 1, okay? This is going to be a consistent situation, and it's going to be independent. It's going to have one solution. And how can I tell that? Because they have the different slopes here, right? So the slope here is positive and the slope here is -3. And so because they have completely different slopes, they're going to intersect each other. But I want you to practice a little graphing. So y equals 3x plus 0, I would think about this as being like 0. It's going through the origin, right? And then I'm going to go up 3, 1, 2, 3, and I'm going to go over 1. I'm going to put another point down. Once I have those 2 points graphed, I'm just going to connect them together. This is equation number 1. Accurate enough for what we're doing for right now, okay? I'm going to graph the second one. So here it is at 2. Let me change to my pen here. I'm going to go up to 1, 2, put a dot down. There's my y-intercept right there at 0, 2. That's my y-intercept, right? Right over there. Now I'm going to try to make a slope of -3. Slope is -3 over 1. That's one way to think about it. So I'm going to go down 3, 1, 2, 3, and then I've got to go right 1 because only one of the two, like the rise or the run, needs to be negative. I happen to put the negative up in the numerator, so I'm making the rise down 3, then the run is +1 to find my second point. You're going to connect those two together. And then what I want you to do is I want you to, write the vocab word that we're trying to use right here. It's consistent, okay, because it has a solution, and it's independent because that is only one solution that we have right there. If I was going to estimate what that is, it looks like over about a third up at 1. So I'm going to say it's 1/3, 1. And I want you to try to do that. I want you to estimate them at each, intersection point. Okay. Hey, let's do another one real quick. I'm going to do number 4 just because it's on the same screen here. And it looks completely different. These two equations are in standard form. I think the quickest way to graph them in standard form is to find the x and the y intercept. So I make a little chart and I put a 0 in for x. If I put a 0 in for x, then I divide both sides by 2 to find my y value, and I get 5. So let's graph 0, 5 real quick. 1, 2, 3, 4, 5. Put a dot down. That is 0, 5 right there. Now I'm going to put a 0 in for y. If I do that, I'm going to cover it up with my pencil, the 2y part, or my pen. And I'm going to imagine taking 10 divided by 6. So I could put that down, 10, 6. It's kind of in bad form right there because, I can divide both those by 2 and I get 5/3, right? So I want to go over, let's see, 1 and did I say 5/3? Yeah, 5/3. 1 and 2/3. I want to go over 1 and then a little bit more, and I'm going to call that right there 10/6 or 1 and 2/3. Okay, so I'm going to put down 1 and 2/3, 0. Or you could put down, if you want, you could put down 5/3. That's the same thing, right? 5/3, 0. Ooh, that one's a little tricky. So I'm going to graph that line right now. Boom. Just connect those 2 points, those two intercepts, right? Notice I never even mess with the slope because if it's in standard form, man, I just like finding x and y intercepts. So here we go. I'm going to do that right up here on this one. I get an x and a y. So if I put 0 in for x, I get y equals -2. Oh, that was easy. Let me graph that real quick. Down 1, 2. There it is right there at 0, -2. Okay. Now I'm going to graph the x-intercept. So I put a 0 in for y, and I get negative 2/3. So let me put down negative 2/3. So let's see, where the heck is that? I got to go over to negative 2/3, like maybe like right in here. Okay, let's connect those 2 points together. And what do these two lines look like? Woo, they look parallel to each other. Now, if you don't put them into slope intercept form, you might have a hard time seeing that they are parallel to each other. Ooh, how could that, not easily could we, do that. If we move the 3x to the other side, we see that the slope is -3, right? Can you imagine that 3x coming over to the other side? So if I transform this into slope intercept form, I get -3x minus 2. If I do the same here, if I move the 6x to the other side, I get 2y equals -6x plus 10. And then I divide everything by 2, I get y equals -3. Oh, look at that. -3x plus 5. See how they have different y-intercepts. There's the y-intercept of that one. There's the y-intercept of that one, right? See the two y-intercepts, and they have the same exact slope. So this is an inconsistent system, okay? Inconsistent system, meaning it doesn't have any solutions, right? And so it doesn't get the special word of independent or dependent, right? So dependent would be if the two lines were right on top of each other, if they had the same y-intercept. If they have different y-intercepts, then it's just called an inconsistent system. Hey, ladies and gentlemen, I really appreciate your effort on this. This is going to be the main part of like graphing them by hand. I want you to put it on paper. This is where, I'm going to stamp this. So let me just do that as a quick demo, right? I'm going to get my red stamp out. I'll come around and I'll look for this kind of work on your paper. So please be putting the graph on your paper, and I want you to record the answers into McGraw-Hill. Thanks for following along with me. I appreciate it.